Hello everyone, in this video I'm going to discuss the example for random variable. So kindly refers to the question. The probability density function of a continuous random variable x is given by the function as below. So refers to the situation where we have the continuous random variable, means that sign is not important. And we have the PDF, so my suggestion is to have the situation in a real number line. So where we have 1 e, the function is k ln x over x. Other than that, we have the function 0. Refers to the question. Question said, show that k is equal to 2. As we all know, they mentioned that it is a continuous random variable. So means that the summation which is equal to 1. As we can see in here, integrate from the negative infinity until infinity for the function fx respect to x, which is equal to 1. So kindly refers to the situation. So where we have negative infinity until 1, where we have the function 0 respect to x, plus integrate where we have 1 until e for the function k ln x over x with respect to x, plus integrate from e until infinity for the function 0 respect to x, which is equals to 1. So as we all know, this one would be equals to 0. So focus for the middle one, where we have to make use of the substitution method. Let u, which is equals to ln x, differentiate the situation with respect to x. So where we will have 1 over x. As we notice that we have the substitution method. So if we can see that where we have 1 over x dx, which is equals to du. So kindly substitute the situation. So integrate where we have k u du. So if we integrate, we will have k u squared over 2. Continue. Substitute the situation where we have the u, which is equals to k bracket, we have ln x bracket squared over 2. We have the limit e and 1, which is equals to 1. So kindly substitute the situation where we have k over 2 bracket. If we substitute e, where we will have ln e bracket squared minus, if we substitute 1, where we have ln 1 bracket squared, which is equals to 1. So kindly simplify the situation. So k over 2 bracket ln e, which is equals to 1, minus ln 1, where we have 0. So finally, as we can see here, we have k over 2, which is equals to 1. Kindly cross multiply the 2. So we will have k, which is equals to 2, and we already shown the situation. Kindly refers to A. Obtain the cumulative distribution function when we have the CDF. So here we have part A, part B, and part C. Kindly refers to the part A, where we have the domain, where we can say t is less than 1 for the function. Integrate from negative infinity until we have t for the function 0 respect to x. So if we integrate the situation, and we will have, so in here we can say ft, which is equals to 0. That is for the part A. Next, we move on with the part B. So in here we notice that it is a cumulative. So means that we have to add on the part A and the part B. So where we have the domain t is greater than 1 and less than e. So where we have negative infinity until 1 for the function 0 respect to x, plus where we have integrate from 1 until t for the function 2 ln x over x respect to x. So kindly focus on this part. Refers to the A. So where we can substitute the situation f1, which is equals to 0. Continue. Plus where we have to integrate by substitution method. Let u is equals to ln x. Differentiate the situation with respect to x, and we will have 1 over x. If you notice that where we have 1 over x and dx, which is equals to du. So kindly substitute the situation. Integrate where we have 2u and then du. So if we integrate, we will have u squared. Kindly substitute the situation where we have ln x bracket square. And then we have the limit, which is t and 1. So if we substitute, and we will have ln t bracket squared minus ln 1 bracket squared. So in front of here where we have 0. So as a conclusion, ft, which is equals to ln t bracket squared minus the 0. Next, for the part C, where we have the domain t greater than e. Again, repeat the situation. Integrate from negative infinity until 1 for the function 0 respect to x. plus integrate from 1 until e for the function 2 ln x over x dx, plus integrate from e until t for the function 0 dx. So as we can see in here, refers to the part B. Actually, we can substitute into the ft, where in here we can substitute f bracket e, which is equals to ln e squared, which is equals to 1. Plus, if we integrate this part, and we will have 0. So as a conclusion, so in here we have ln e bracket squared. So in here, finally we have ft, which is equals to 1. Kindly rewrite the situation where we will have the CDF, which is equals to, the first one is 0, followed by ln x bracket squared. Finally, we have 1. So refers to the domain on the left hand side where we have x less than 1. Then x is greater than 1 and less than e. Finally, x is greater than e. So here we have the CDF. Next refers to B. Determine the 81st percentile for the distribution of x. So in here, the meaning of 81st refers to 0.81, which is the probability. So in here, we have two ways of answer the question. Number one is by using the PDF. So in here, as we all know, integrate the situation negative infinity until the x for the function fx dx, which is equals to 0.81. So refers to the situation. So integrate where we have 2 ln x over x respect to x for the limit where we have 1 until x, which is equals to 0.81. So kindly integrate the situation. So let u is equals to ln x. So differentiate the situation and we will have 1 over x dx. So again, repeat the situation. Integrate where we have 2u respect to u. Finally, u squared will be the answer. Next is to substitute the u. So if we substitute the u, where we will have ln x bracket squared with the limit x and 1, which is equals to 0.81. So if we substitute, we will have ln x bracket squared minus ln 1 bracket squared, which is equals to 0.81. Continue, where we have ln x bracket squared equals to 0.81. So next we have ln x, which is equals to square root of 0.81. So here we have plus minus. So we will have to ignore the negative because we can see in here our domain is in between 1 and exponent. So it is impossible for less than 1. Next we have x, which is equals to exponent. We have the power square root of 0.81. So by refers to the calculator where we have the situation 2.459. If we round up the situation, 2.46. So that's why we only take the positive square root, not the negative square root. So here we are using the PDF. Next, we are going to make use of the CDF. So in here, as we all know, we have the fx, which is equals to 0.81. So kindly substitute. We are using the second function. So ln x bracket squared, which is equals to 0.81. And we notice that we have ln x, which is equals to square root of 0.81. And then x, which is equals to exponent to the power of square root of 0.81. So finally, x is equals to 2.459, or we round up, we will have 2.46. Next, we have C. So ex, where we have the formula, negative infinity until infinity for the function x multiplied with the fx respect to x. So that is the formula for expected value. Continue, where we have integrate x multiplied with the situation where we have 2x ln x over x respect to x for the domain where we have 1 until e. Simplify the situation. Integrate, we have 2 ln x with respect to x. By using by part, where we have u, which is equals to ln x. And then we have the dv, which is equals to 2 dx. Differentiate the situation and we will have 1 over x dx. Integrate the situation and we will have v, which is equals to 2x. Kindly substitute the formula where we have uv, which is 2x ln x minus integrate the situation where we have v multiplied with the du, where we have the situation 2 dx. 2x ln x minus 2x plus with the c. So in here, we have the limit, which is e and 1. Kindly substitute the situation where we have 2e ln e minus 2e bracket minus, substitute the 1 where we have 2 ln 1 minus 2. Simplify the situation. So in here, we have 1, then we have 2e minus 2e, which is equals to 0. Minus, here we have 0, so we have negative 2, so plus with the 2. So finally, the expected value will be equals to 2. So here we are, and thanks for watching.